Properties of logarithms. If you've not done the do now, pause the video first and try them. The key ingredient here is that you're looking for what should I raise 3 to get 3 to the 5th. So like hopefully you're getting past the point where you got 3 is to the x is equal to 3 to the 5th. Oh, I need to raise it to the 5th power. That's really heavy-handed, that one is. And then for number 2, it's the same. What should I raise x to get, what should I raise 5 to get 5 to the x power? It's going to have to be x. Next one, what should I raise b to get b to the 4th? It's going to have to be 4, except I need to put some restrictions on here because this b down here cannot be negative and it cannot be 1. We've discussed that when we first defined logarithms. And for 4, question number 4 is the same thing. The base here and here match. So therefore, I would have to raise b to the x plus y to get b to the x plus y. It's almost like self-explanatory there. All right, so we're ready to rock and roll. Again, just remembering that the 3 and 4th both needs some restrictions. Let's think back of our exponential rules. For example, a to the m times a to the n. What do we do with those exponents? We end up adding the exponents, a to the m plus n. If you don't remember why that's the case, like try some with numbers, like a to the 3rd times a to the 2nd is the same as a times a times a times a times a. Oh, look, that's a to the 5th altogether. It works the same as just adding the exponents. What do we do with the exponents? We added exponents. Okay. For all positive numbers m and n and b, where b can't equal negative, this is one of the properties of logarithms. So one of the things I want you to think logarithms are, they're exponents. So the rules that work for exponents work for logarithms as well. So in this case, when we're multiplying with the same base, we end up adding exponents. So here you're multiplying with the same base. You can also rewrite it as an addition. Now that doesn't seem very obvious, and I understand why that could be completely confusing, but we're going to actually prove this. So the way to prove this is that we're going to let x equal b log base b of m and y equal log base b of n. So in other words, this is basically down here is x and this is going to be y based on our proof here. Step number 1, convert to exponential form. So that's what I'm going to do. I'm going to rewrite each of these in exponential form. So for the first one, x is equal to, the base is b, and the exponent is x, which then is equal to m. So those two things, if I highlight that in yellow, this one here in yellow and this one here in yellow, they are equivalent. They're the same thing. It's just a different format, right? And then for the second one, we end up with n is equal to base is b and the exponent is y. So that's going to be in blue. These two here, this one and this one in blue, those two are equivalent to one another. Okay, once we've done that, we're going to use by multiplication property of equality. I'm going to multiply by the same thing on both sides, right? So it doesn't seem super obvious in the beginning, but look, if I take m, and I'm leaving some room here so I can multiply, and that's equal to b to the x power. I'm going to multiply both sides by n by the same thing. But wait, n on the right-hand side is equal to b of y. or b to the y, not b of y, b to the y. So in other words, I'm multiplying by something that's equal on both sides of an equal sign. So that's why that's multiplication property of equality. And then we're going to use addition property of exponents. Addition property of exponents. It's one of the properties of exponents, right? We just discovered or reviewed that up at the top. I know that m times n is equal to b to the x plus y, like that. And, oh, I'm out of room, so I'm going to have to move that over here. So what color should we go back to? Red, maybe. Convert back to log form. So look, the exponent is x plus y. Log, the base is b, and now we have m times n, like that. And then we're going to use substitution. By substitution, I can say that log base b, if you want to be technical, I'm also using reflexive property. Maybe I should flip-flop those two, right? Plus reflexive. Oh, yeah. Reflexive property of equality, because I'm switching the log base b of m to the other side of the equal sign. Basically, that's equal to x plus y, but x was defined as log base b of m plus log base b of n. And my b's look like 6s. So then we have proven that that's the case. What does that mean in terms of like doing problems with this? Just a little aside here. So we're going to look over here on the side. Let's say I had something like this. Log base 5 of 3x, like that. I could actually rewrite that as log base 5 of 3 plus log base 5 of x. I could write them as two separate things. Now that doesn't look super helpful, but let's say I had log base 5 of 5x instead. I could write that as log base 5 of 5 plus log base 5 of x. Log base 5 of 5 I know is actually going to be 1, because what should I raise 5 to get a 5? That's 1. So this is going to be 1 plus log base 5 of x. So that it lets us, what it's called is expand. It lets us expand a logarithm. We can separate things that are being multiplied by addition signs.